This video will cover solving single variable equations. I'll be using the language of the college preparatory math curriculum of flipping, removing zeros, and balancing. So here's a description of the steps that I would go through. Flipping as needed. I would do that if I have in my equation, anytime I have a negative sign or a subtraction sign in front of parentheses, I would flip everything inside those parentheses. Or if I am taking away a negative value, such as taking away a -4, anytime you are taking away losses, you end up gaining. So I would change that to a +4. And then the next step would be to simplify the left side, simplify the right side. That would be through a series of removing zeros or combining like terms. They really mean the same thing. And then once the left and the right side is simplified, balance with the goal to get one variable term on one side, or the variable term on one side, and all of the units on the other side. Be sure that you end with the value or values that one variable is, can, or cannot be. Most importantly, do not stop until you have one of three things. So the first column has different values that x can be, whether it's negative, positive, fraction, decimal even. That is the one thing to stop at where you know what the value of x is. The middle column shows values where the variable parts have been wiped out. There's nothing left. They've been balanced on both sides. And you end up with something like 3 equals 3, or -5 equals -5, or 2/3 equals -2. These statements are all true. But that's not the place to end. You cannot end until you identify all the values that x can be. So in this case, if x is the variable, so my final answer would be x is all numbers. On the third column, these values again are indicating there is no variable left. The variables have been wiped out, they've been balanced off of both sides, and we end up with something such as 3 equals 7, -2 equals 5, 2/7 equals 1. When we know that these are false statements, what that means is that the left side is not equal to the right side, and never will be. But that can't be our final conclusion. We can't just say it's false. We have to identify what are all the values that x is, can, or cannot be. So our final conclusion, therefore, x has no solution. So your final answers will be something like, oh, I found that x equals -6, or x equals 5, x equals 42, maybe even x equals -3/4. If you have something like the middle column, your conclusion should be, therefore x is all numbers. If you have something that ends in the third column, your final answer would be, therefore x has no solution. Okay, for this first problem, I want to point out the equal sign in the middle separates the left side and the right side. And it's important that we really focus on what's on the left and what's on the right. So I'm going to draw a gray line there to remember to keep the left and the right side separate. And then as I begin solving the problem, first thing I usually do is to take care of any parentheses if there are any. In this case, neither side has parentheses, so there won't be any flipping on this problem. And then the next step would be to simplify the left side, simplify the right side. So I'm looking at the left side, and I see that I have 6 positive x's, and I have 7 negative x's. So that is a subtraction sign, but we can also refer to that as being negative or opposite. So I'm going to describe this as being a -7x. So I have my 6 positives, my 7 negatives. All 6 of the positives will cancel with all but one of the negative x's, and that will leave me with a -x left over. For the units, I have 5 negatives, I have 3 positives. The 3 positives will cancel with 3 of the 5 negatives and leave me with 2 negatives left over. On the right hand side, I have 4 negative x's and another negative x, giving me a total of 5 negative x's. On the right hand side, I have 3 positive units, 4 negative units. All 3 of the positives will cancel with 4 of the negatives, leaving me with 1 negative unit left over. So now when it comes to the next step, it would be balancing. So my number one goal in solving an equation with a single variable is to get that variable by itself on one side of the equation. It doesn't matter if it ends up on the left or if it ends up on the right, but it needs to be by itself. So all of the units need to be on the other side. I typically like to have my x values be positive, although it could go either way. But I notice that I have a greater value on the left-hand side. So -1 is a greater value than -5. So if I put them on the side where there's a greater value, that will make them be positive. So I'm looking at the other side, the right-hand side where they are, and there's a -5x. The opposite of that is 5x. When I add the opposite, they cancel, they become a zero pair, and to keep it balanced, I have to add 5x to the other side as well. So on the left-hand side, I have a -x and 5 positive x's. That will leave me with 4 positive x's. Okay. Now the next step then, I have all my x's on the left-hand side here, but I have these units hanging out with them. I don't want the units there. So I want to make them go out and be able to cross them out. So the opposite of a -2 is a +2. If I add 2 to this side, those will be gone. But to keep it balanced, I have to add 2 to the other side as well. On the left side, I now have 4x. On the right side, I now have -1 and a +2 leaves me with a +1. Okay. On the left-hand side, I have 4 x's. On my right-hand side, I have all my units. So that's what I was hoping for. But I still have more than one x. I have 4 of them. So I'm going to divide them into 4 groups. And if I divide the left side by 4 to get my single x, I have to balance it by dividing the right-hand side by 4, and I end up with a value of 1/4. So my final conclusion, x is equal to 1/4. So with this problem, it has parentheses, so I need to look at flipping, and I see that there is something that is indicated that it's in the opposite region. This one's in the positive region, so this one needs flipping, but this one does not. And then this one over here is in the opposite region, so these pieces need to be flipped into the positive region. So starting with my divider, first thing I'm going to do is my simplifying, and that would involve the flipping. So my -2 gets flipped and becomes a +2. The +3 in the parentheses flips and becomes a -3. And then the second set of parentheses is already in the positive region, but I'm going to ungroup it by removing the parentheses. On the right-hand side, the 7x and the -3 are already in the positive region. In the opposite region, I have 5x. When I flip that, it becomes -5x. And I have +6 units. When I flip them, they become negative units. So now I'm ready to simplify by removing zeros. So on the left-hand side, I have 2x and 3x. There are no zeros to remove. I'm just going to combine those like terms. And then for the units, I have 3 negatives and 8 positives. When I remove zeros, I will have 5 positives left over. On the right-hand side, I have 7 positive x's and 5 negative x's. When I remove zeros, I will have 2x positive left over. And for the units, I have 3 negatives and 6 negatives. No removing zeros, I just combine those like terms and have 9 negatives. Next thing I'm going to do is put my x's on one side, and I see that I have a greater value of x's on the left-hand side, so 5 of them compared to 3. So I'm going to move my x's to the left-hand side. So that means that I do not want my x's here. I want to be able to cancel those out. And there's 2 positive x's, so if I add the opposite and have 2 negative x's, they will be canceled. So I need to balance by taking 2 negatives off of the left side as well. So my x's, when I simplify, I have 3x. I'm going to go ahead and do my units at the same time. I know that I don't want my units on this side because that's the side I've reserved for my x pieces. So I want to take these 5 off. I want to be able to cancel them out. So the opposite of a +5 is a negative 5. So they will be removed from the left. On the right-hand side, I already have negative pieces, so I'm going to just add more negative pieces. So altogether I have 14 negative units. So next step is balancing by looking at the fact that I have 3 x's on this side, but I only want 1. So this time the balancing I'm going to do is dividing this side by 3, so I have 1 x, and the balancing is dividing the right-hand side also by 3, and I end up with 14/3 negative. So x is equal to negative 14/3. I could turn that into a mixed number, but often in algebra the improper fraction is going to be the preferred answer. So again, I have parentheses, and both of those sets are in the opposite region, so I have some flipping to do. So on the left side, the 5x minus 3 does not get changed, but then I have the opposite of 2x, making it negative 2x. And then in the opposite region is a negative 9, making it a positive 9. On the right-hand side, I have the negative 4x plus 8, and then I have the opposite of a negative 6, making it a positive 6, and the opposite of a negative 7x, making it positive 7x. On the left-hand side, I have 5x minus 2x. That would leave me with 3x. Negative 3 plus 9, leaving me with positive 6. On the right-hand side, I have negative 4x and positive 7x, leaving me with 3x. And then I have 8 plus 6, leaving me with 14. So I need to put x's on one side, but I notice that there are 3 x's on both sides. So if I can't put x on one side, but I can remove them. I can balance them. And when I do so, I have 6 on the left and 14 on the right. Well, this is a false statement. This is not true. This tells me that the left side is not equal to the right side. If the left side is not equal to the right side at this point, that means the left side will never be equal to the right side. My final conclusion, the values for x, there are no solutions. So x has no solution. And that is my final solution. My final answer is that x has no solution. In this problem, both the left and the right-hand sides have parentheses, but the one on the left is indicating it's in the positive region, so I don't need to flip anything, I just need to remove my parentheses. Over here, this is in the opposite region. I do have to do some flipping. So, copying the left-hand side as is. Oops. So the opposite of 4x when flipped is a negative 4x, and my positive 2 when flipped, the opposite of that 2 becomes negative 2. On the left-hand side, I have negative 7x and 12x. That leaves me with positive 5x. And negative 5 plus 2 leaves me with negative 3. On the right-hand side, 9x minus 4x leaves me with 5x. And my negative 1 minus 2 leaves me with negative 3. So again, I have 5x on both sides. So I can't really move x's to the left or right because there's the same amount. So I'm just going to take them away. They are gone off the left, and they are gone off the right. That leaves me with negative 3 units on the left and negative 3 units on the right. Negative 3 is equal to negative 3. This is a true statement. This tells me that it's guaranteed that the left side will be equal to the right side, regardless of what x is. So therefore I know that my final solution, my final summation, is that x can be any number, or I'll simply write x as all numbers. The left side will be always equal to the right side, no matter what value I use in place of x. That is my final answer. So this time I'm going to show you a common mistake that students do. They might look at the 2x and the 3x and they see that opposite sign there, so they write down negative x. And then they look at the negative 2 and the negative 8 and they write down negative 10. Well, that would be an error. So we'll look at it the correct way. So it would be a 2x minus 2, and then the opposite of a 3x, making it negative 3x, and the opposite of a negative 8, making it a positive 8. So when we simplify that left-hand side, we do get negative x, but then the negative 2 and the positive 8, we end up with positive 6. Let's go ahead and finish the simplifying the right-hand side. So let's say somebody just prefers the x to be on the left-hand side. They might take 3x off of both sides, and they end up with negative 4x on the left-hand side. And then at the same time I'm going to take 6 away because I might as well take away the units now to be more efficient with my time. And 18 minus 6 is 12. So I have negative 4x on the left-hand side. I can still work with that as long as when I divide them into groups, I divide them by the exact same value as the coefficient of x, which is negative 4. Because negative 4 divided by negative 4 is 1, I end up representing 1x. And then on the right-hand side, 12 divided by negative 4 leaves me with negative 3 as my solution.